Okay, so last time we talked about simple series circuits. Today we're going to talk about their counterpart, simple parallel circuits. So this is what a parallel circuit looks like. Instead of the two resistors being connected end to end, they're connected in parallel side by side. So it forms a second pathway for the current to flow. A second loop is sometimes what they call it. So you still have a voltage supply, but now you have one resistor going this way, and then another branch splits off, and you have another resistor going this way. This right here is called a junction or a node. So the current coming out of the battery, when it gets to this node, it splits. And it will split according to the resistance in each pathway. And there doesn't have to be just two. There can be three, four, five. There can be an infinite number of pathways, an infinite number of resistors. But the fundamental properties of a parallel circuit are different. So, for example, the voltage drop across each branch is the same because this part of the battery is connected with a wire to this part of the circuit right here, to this node. So whatever the voltage is for the battery, the voltage is the same at the top of both resistors, and then at the bottom, they're both connected to ground. Because of that, let's say this battery was a 5-volt battery, each one of these resistors gets an equivalent 5-volt drop. That's different. Um, Also different is the fact that the current isn't the same everywhere. The current coming out of the battery splits. So if these two resistors are different, the current in I1 might be different than the current I2. Okay, so that's different. The other thing that's different is adding resistors in a parallel circuit does not add resistance to the overall circuit. It actually decreases the resistance of the overall circuit. So you can't just find the resistance by adding them up. You have to use this inverse equation. So 1 over the total resistance is equal to 1 over R1 plus 1 over R2 plus however many more there are. And in order to use this equation easily, some of you will have a button that says x to the negative first power on your calculator, and I'm going to talk about how to use that too. The best way to do this is to show some examples. So here we have a 12-volt circuit, and we have two resistors. They're equal at 5 ohms each. So this is your parallel circuit. There's two parallel branches. Here's the rules. First of all, the total voltage drop across each loop, so here's loop 1, and here's loop 2, it still has to be the same. So this is what I was talking about. They're each going to get a 12-volt drop because the top of the battery is connected to the top of each resistor, bottom of the battery is connected to the bottom of each resistor. So 12 volts is going to be the drop across each resistor. If one of these was larger and it had a different amount of current going through it, then the voltage drop could be different, but that's not really the issue here. The node rule comes into effect. So here's the 12 volts. The node rule comes into effect when the current comes out of the battery. It's going to get to this first node, and it is going to split into two different currents. So in the first resistor circuit, the first loop here, we'll call this I1. In the second loop, that'll be I2. And then they rejoin at this second node right here to form the exact same total going back into the battery. Okay? Here's the math. To find the resistance for these two resistors in parallel, you have to take 1 divided by the R total equals 1 divided by 5 plus 1 divided by 5. So I'm just going to show you this in the calculator. You can do it like this. 1 divided by 5 plus 1 divided by 5 equals, but then that's not your answer. That's 1 divided by your answer. So you would have to go 1 divided by your answer, and that would give you the total resistance. So this is the actual R total. The way that I prefer to do it is to use the inverse button. So if you go 5x negative 1 plus 5x negative 1. So this is the same as doing 1 divided by 5 plus 1 divided by 5. Then you have this, and now you can just go negative 1 again. That flips it, and that gives you your answer. Either way, we get the same answer, 2.5 ohms. So this is the total resistance put out by this circuit. Notice each individual resistor is 5. The total here is 2.5. It's half of each of the originals. So the resistance has gone down, which means that more current is going to come out of the circuit. So to find the total current coming out of the circuit, you take the voltage divided by the total resistance, 12, divided by 2.5, and you get 4.8 amps. Well, that's going to split right here. And because these two are equal, each branch is going to get half. So 12 divided by 5, you still follow Ohm's law. So for each resistor, you know the voltage drop is 12, so it's 12 divided by 5 gives you 2.4 amps. It's going to be the same thing over here. Well, what if the resistors are not the same? Okay, so here you have the exact same circuit with one difference. You've got a 10 ohm resistor now instead of just two 5s. So you still have the nodes. The current is still going to split, but now it is not going to split evenly because there's a greater resistance in this resistor than there is. This should say R2, by the way, that's a typo. The second branch has a greater resistance, so it's going to have less current than the first branch. Okay, so here's how the math works out for this. You go 5 to the negative first plus 10 to the negative first, you get 0.3, but then you have to flip that, take 1 over that, and so this is your total resistance. That's what I'm showing you right here. So 1 over 5 plus 1 over 5, I had to fix that. 1 over 5 plus 1 over 10 equals 0.3, and then when you take 1 divided by 0.3, you get 3.3 repeating ohms. I also fixed this so that it says R2 here. So notice again, the total resistance is smaller than each of the two individual resistors, which pulls more current out of the battery. So 12 volts divided by 3.3 ohms gives you 3.6 amps. Well, now you have to figure out the current in each branch. Branch 1 is actually the same exact inputs as last time. You had 12 volts divided by 5 ohms, so you still have 2.4 amps over here. Going into branch 2, you have 12 volts divided by 10 ohms, which gives you 1.2 amps. Notice 2.4 plus 1.2 still adds up to the total. So the 3.6 comes into node, splits, and then and then it's going to go back into the node and come back into the battery at 3.6 amps. This is the basics of some simple parallel circuits. Now let's practice.